And we are recording. Welcome to the evening of Python coding. It's the meetup that shows you a different Python library or tool. We gather once a month. And this month we have Lorenzo Veschini, sorry, I promised to get the name right. And he's gonna tell us about a library called Zarr. And Lorenzo and I know each other from the biomodeling community. He will give you some tips about how this can be used for some real life biomodeling also on top of what Zarr is. So Lorenzo, the floor is yours. Go ahead.
Thank you, Jacopo, very much. Hello, all. I'm Lorenzo, and let me share my screen so we can see what we're talking about. And it should be on. I hope it's fine. Can you confirm that it's all okay? All good, fantastic. So I start with a Git, an open Git that you can access. The link should be in the chat, pinned in the chat, and is what we will be doing today. So there is if you want to install the library, I put in some YML file that you can use, and there is a Jupyter notebook that you can follow along. It's all very simple, but you can use that, and it's an open repo, so you can use it. And what we will do, we will demo the Zarr library, which is a library in Python. So Zarr is a specification for chunked, compressed, and dimensioned arrays, but you look at the Python binding. Again, it gives us an efficient way to store and manipulate large data sets, large arrays, multidimensional. It supports a number of storage backends, local system, interesting cloud, if people are doing things in distributed environments. And again, it has binding for different programming languages, including Python. You can, if you go at the repo, there is a link to the documentation, which is this website, which is way more complete than what I will show you today. So whatever is missing from today's demo, which is much, will be, you can look at that there. And I put a link there, so for your convenience. The general idea, what is Zarr? This is the image that is on the same website, and is a specification for creating this kind of storage. Like you have hierarchical structure, like a folder structure in our computer, and in fact, it looks like exactly a folder structure in your computer, which can be grouped, subfolder, and nested at need. And at the end of the leaves will be arrays, multidimensional arrays, like NumPy arrays. If we work in Python, you probably know very well what I'm talking about. And the specification works a lot on chunking, so dividing in equal parts our array for storage, for convenient storage, compression, providing facilities for good compression, and then accessing, writing, and reading this kind of file, this kind of data structure fast. Again, the kind of access that you have is like a folder structure, and we will see that. And you can also store metadata in this kind of structure. And for example, in a hierarchy, you will have a root, which will have its own metadata. And any group that you create can contain metadata. So you can always, and metadata are stored like in a JSON format. So they are the usual Python thing. You can be funny about things you put in it, but I wouldn't advise being funny. I would stick to lists and numbers and things like that. But it's a good plus. And that's all for the intro. I think What is shown in the demo is the same that I will kind of show you using VS Code. And I'm taking slightly longer if people want to download and play along with us. And so I will discuss what we do today. So we will create arrays and group in Zarr, store read JSON metadata via attributes, configure chunking and compression. Really, we will just over that. Show how we can take our array, our Zarr store, and turn it to a zip for storage, for kind of sharing as a single file. Managing Zarr store with the manager class. This is a kind of beginning to play with an applied example. And then this is just, I just put in a little boilerplate flow code, like an exercise, how we can use Zarr for a PyTorch data loader. Why would you do that? I think in the demo I will show you reason why you might want to do that. All right. And if you don't know what I'm talking about when I say PyTorch data loader, you might look at the link here. That is something that is used in AI to access data in an efficient way. What you need, important distinction, and so I mention it here, is also in the demo. Python more than 3.7 if you want to do specs v2 version 2, or 3.11 if you want to start with v3 straight away. Since Python 3.10 is going to end of life very soon, and if you have never used Zarr, I would just say just go for v3, unless you have a binding in your particular application to Python before 3.11, and then you will fall back to v2 automatically. So just be aware of that. Then no big requirements are NumPy, because well, we don't do much really. Setup is really the standard thing with a Conda, so I won't lose your time. I assume that you are very much into that. If you are not, try to follow the instruction. Otherwise, this kind of standard ways of installing an environment, isolated environment to have code in your computer and run Python stuff. All right. So if there is no question about this bit, I will just go on to the demo and you let me know if the code is clear. It's all good? Yeah, fantastic. So if I don't see any resident or questions, so I will just repeat what we will do. We create arrays and groups, store metadata, look at chunking and compression, looking with zips, a manager class, user Zarr and PyTorch data loader. And I will also demo just a little cell of code to demonstrate you that you can write concurrently many files at once in your Zarr thing. And we will look at how they look in the data structure as we go, okay? So raise the hand.
Yeah,
Any question?
do we need Windows or Mac to use this?
Sorry?
Windows or Mac so I can do this. And can you help me get it set up?
Any system, Linux, Mac, and Windows. Conda, you need a Conda environment. Well, you don't need it, but the Conda environment helps you doing that according to what is in the repo. And once you have Conda in your computer on Windows, you have to install Conda. On Mac too. Well, in all of the three you have to install, but in Mac and Linux is kind of straightforward.
Okay, I have Mac, so can you send me the link?
So, Jacob, can you help them to install Conda?
Okay, thank you.
You are muted, Jacob.
Sure, I'll do this. I'll pull out the link and put it in the chat. I ask you, Don, since we do want the demo to finish in a reasonable time, so Lorenzo will continue with the demo. I will send the link, and you will have to install an Anaconda or Conda and then do this, which will take a little bit of time. So since we're recording this, you can later come back to the recording and follow up with the recording. The recording will be out tomorrow or the day after. So
Okay, thank you. I appreciate. Thank you. God bless.
for now, look, but you'll need some tools. You need some Conda or Anaconda. You can do it without, but it's better to do it in those environments.
I will take notes.
Okay, so I will send you the link now.
Thank you.
Go ahead, Lorenzo.
Okay. So first thing first, well, this is a Jupyter notebook that you see. You see that there are cells and some markdown. Jupyter is a convenient way to do this kind of demos because you can run code with Play, but it needs a little bit of setup if you want to play that way. So I put a very quick instruction, and I'm using Zarr demo v3 as a configuration file. If we want, we can take a look to that. And fantastic. So perhaps I'm a little bit saying things that people know already, but I don't want to obviously.
Lorenzo, trying to aim towards beginners, people who know this. It's okay. Trying to aim towards beginners if you can. Thank you.
So that's so good to see what we do in terms of the environment, at least what we need. This is just stuff that is needed for Conda, but if we want to use Zarr 3, we want Python. I put 3.12. PQDM is an interesting library to check out, having nice track bar if we do a lot of processing. Zarr, our friend for tonight. Explanation again of the point of version 3, version 2, NumPy, Matplotlib to make a plot, JupyterLab, and IPY kernels, which are needed. One is a notebook, similar to the one we use. Kernel, in VS Code, it comes almost for free. Really, if you don't have IPY kernel, it will install it for you, will tell you that you don't have it. PIP as usual, Pillow for a little bit of the demo that I want to show you. And I will skip fast on this. This was just to show you which kind of imports we will use. And this case here is just a header to, and we can click play on this. It will take a second, and it tells us just the things that we have done. Python, I'm on a Mac, Intel. I have installed NumPy 3.2.3.1. Since it's Python 3.12, I have Zarr version 3. So nothing big here. And if you run this code and you have some issue on why it's not working or not sure what number to put below, you can just look at this. Create store. This is explicitly done for a demo. So I created this variable where you can say to yourself which version is there. I could have asked it automatically, but it's just, come on. Is useful like this. And so I'm using 3. There won't be very big difference, and I will highlight those. So, but then important to see that there are different. They have changed things in V3, and so it's important that you are very aware of which you are using, because there is back compatibility from V2. V3 can read V2, but then they're not the other way around. So it's important that you know that. So what I do, okay, which Zarr version are we using? And then we create some data, some fake data, NumPy, random, an array that is relatively small, 100 by 100, float 32, not the cheapest data type, but not even super expensive. Then we want to have a sparse array. I guess everybody is aware what is a sparse array, and is an array where.
Sparse array for people, because this is something that they may not understand.
Okay, sparse array is an array which contains a lot of zeros, and a lot means a sizable percent. In our case, our sparse data is everything that is smaller than 0.8 and is being randomly casted from 0 to 1. So about 20% of our data here won't be non-zero. Something like that. Okay. Parse data I created with an NP random 1000 by 1000, float 32. And then I say all of that is smaller than 0.8 becomes 0. Only what is bigger than 0.8 becomes stays whatever number it was. So about 20% of our data will be non-zeros, and this makes it sparse. Sparse meaning that there is not very many data really. And this, well, why are you doing that? Is that something useful? It is, because in very many instances of data in biology, but I guess also in other part of data science, data are sparse. So many binary images are very sparse. 50% or more of the pixel are 0, and then so on. And there is some interesting consequences that in handling sparse or non-sparse data. So now this code is me defining the place where I want to put these Zarr stores that we are going to create. We create one for the random one, the other for the sparse one. Dependently on which version we are using, we are, yeah, this is an if else. If it's 2, it will go here. Otherwise, if it's 3, we'll follow the other one. And here I'm showing you essentially only this, because then I have a cell where I explain how it's done. So there is compressor. So we can choose which way the data in our store are compressed, if we want them compressed. And this is useful for a number of things. Sometimes we want to save space, and sometimes there are algorithms of compression that are faster or slower. So we have to find a trade-off between to find the right algorithm that make our I/O fast enough for us and makes it efficient in terms of storage, in terms of how much we gain, how much our data that in memory will occupy that much, how much they occupy on disk. Might be an advantage, you might not care, but it is an important feature that is there. And it is both in V2 and V3. In V2, you will do it like this. You define a compressor, and this is in the library. And then you define its name and a bunch of parameters. You better read the guide for really having a touch over what it does. And in V2 is useful to set it up because the default does so and so. And nothing. Then we create a store, Zarr store, Zarr open, the name that we defined before, mode we are writing. We are creating an array, so we give it a shape, and we know that we're putting our data, so we just give it the shape of our data, the type, the data type. We can define it or not, and we assign a data type. We want the compressor, and we give the compressor that we defined before, and the chunks. So the chunks are, if our array is 100 by 100, and we make chunks 50 by 50, we will have, I think, 4 chunks. Yeah. Okay. So this is a way that Zarr stores data. You can have chunks that are the same, exactly the same size of your array, or you can have smaller, and so they are separated. Sometimes it's advantageous, sometimes it's not. So yeah, that is. For the sparse data, we do exactly the same, so I won't repeat myself. Else, we are working with V3. So very identical story. The only difference in this particular case is how we would, if we want, define the compressor, which in version 3 have become codec. They changed the terminology and the way which parameter you put. And if you would define your compression, you will define a codecs list, a pipeline of codecs. Again, please refer to the guide to do this with conscience. And then your command to create your store will be Zarr open, name, write, shapes, type, and instead of compressor, you will say codecs. And they will do also different kind of stuff. You can tweak it much better. And if you know what you're doing, these for sure advantages. I found out for my example here that no codec define was the best option in terms of showing you compression and this kind of stuff. And so I leave it just here as a comment for reference. Then it's exactly the same. Zarr open, the name, write, because we are writing, shape, and data types. And then when we have created the stores, but we haven't put the data, but then in our store, and we slice it as an NumPy array, we put our data. And that's it. So if we run this, it will be surprising if the demo doesn't work in this particular case. And so we have the OK. And what I can show you, I better show you it here. Since I am sharing. OK, fantastic. So, all right. You see that we have created something random example and sparse example. How do they look like? Random example, Zarr, our data, and these are data, essentially. Let me see that this is sparse example looks at exactly the same. And then you see, okay, the sparse has been chunked slightly different because I define a different chunking. This is interesting, so we can look at that. No, well, it was automatically chunked. So is since they are different size, it chunked automatically in a different way. Okay. And we have this JSON file that we will look at later in a minute. So here we go. So the example is done. And so once we have our data, I have these cells that, to be completely honest, I've already explained really. When you open a Zarr in this way, you open it, which means creating it if it doesn't exist. Mode write, you have different modes, refer to the guides, and you have option to say, okay, write and overwrite, write only if exists or none or empty, etc., etc. Shape and dtype, if you define it's useful. Compressor, we discuss it. Chunks, we discuss it. And here, this is the explanation, a little bit of documentation. So you can click here and find your way through codecs if you wish so. And yeah, just comments about to determine optimal chunk size. You will consider the access pattern of your data and really play around, experiment, and see what works best in your case. All right. We have written the data. It's very useless in my particular case because Jupyter notebooks are fine in a number of ways, in the sense that they are useful, not funny in the sense that they are strange. They as you go along, they save your data or the variables that you define in your environment. So as long as you don't restart the environment, you have old environment. But well, for demo purpose, I want to load the data anyway. And so how I do that, I open it with the name exactly as before instead, and I change the mode to read. And let's see what happens. Voila. So data loaded, okay. And then I printed the data themselves. And since I have the sparse example, I print the sparse example, you see how many zeros there are around. All right. You let me know, guys, if everything is going fast, slow, right about time. So I'm assuming if nobody stops me that things are going well. All right. I
Let's
discussed
see
it.
how well it compressed. I'm curious.
Sorry?
I'm curious how well it compressed. Let's see.
Yep.
Run it.
Let's run this. Whoa. Let's do it again. It didn't compress at all for the original data size for some reason. In this particular case, I don't believe it. Let me do it again. I don't need to load them. Voila. This is the standard. There is always a little bit of compression. That might be there was something in that particular array. And normally, if you have a normal array, you don't gain very much in compression, but this is 100 by 100. There is not much to gain, I must admit. Now we can play around. I can make it bigger then, so we can play around a little bit. But I've taken a sparse one, which is big. Well, it's bigger. It's 1,000 by 1,000. It's a normal image. In AI, you will use image by 512 or 256, but 1,000 is not a particularly big format. So, but this one is being quite compressed, in my opinion, and it's convenient. You have, and it's a lossless compression. So you see that it doesn't compress a lot. If you have data, if the data are dense, the compression, is not so very much. I want to, since you asked it, I want to play at this point. I want to make also the other array bigger. Why we should be smaller? And let's go with it. It gain a little bit, but you see. So the compression, I believe, is good. What do you think, Jacob?
10% or 18%? It's like it's 10%. Yeah, pretty good.
10% is okay, but the good one, if you know that your data are sparse, then you gain a lot. And if you know that...
Wait a second. The 10% is for is how much you gain or how much you compress towards.
Is how much you gain. Is 1 minus...
1 minus. In that case, the compression for the sparse one is much better, of course.
And is useful because if you have data that are like, you might think about engineering your data to pass them in a convenient way, just that. So that's why I think it's useful to look at those. Okay, if there are no questions over this bit, we can go to the, perhaps it's not different at all, but is the most interesting part, right? So we creating an array and compressing it. All right, there is plenty of stuff for doing that. Why I need a Zarr. So I have. It looks like more complex, overdoing. The interesting bit is when we can group and create a whole hierarchy and a data structure, our own spatial data structure or our own application or tool. So group it, create a hierarchy of data. What we will do again, version 2, version 3, Zarr version 2 as is version 3. And you see this dashed line because my environment has v3 and create dataset has been deprecated or is on the way to be deprecated. So when we use v3, we use this other way of saying things. The logic, to be completely honest, doesn't seem to be very different. The idea is that you create a new storage Zarr, open our usual stuff. You give a name and you say it's writing. We call it root, and you don't put data in it. You see, we open without specifying data, nada, nothing. Then, in a nice way, you create group one, and from root, you create another group. And you can go on like that, and create group two. And then in group one, which we reference here, you can create an array of data, 1, 2, and 3. Might be different, might be the same, as far as you respect the rules for specific data. It doesn't like rugged array, for sure. There are ways to handle those, but it doesn't like rugged stuff. So you have to think about your data structure if you have rugged data types. But if it goes as far as having an array of different size, we are perfectly fine. Huh? So this is how we create a structure that if we run, let me grab again my file view, my grouped example, which is unsurprisingly has done exactly what we'd expected, and the data look exactly as before. Yeah. So now I'm not really using all the specifics in all example, but you imagine that you can really specify everything you want in your data, your chunking, your compression. You can do whatever you want. And I assume you want to do something in a kind of standardized way, but it's very open, I think. And so V2 just changed the name. The way you call things, but is very much the same. And then we have a part that I really like, I think is important because, and now I'm telling you a little bit of my work just for that, really. The rest is not much value. One of the reasons I came to Zarr was also about the metadata. So I was thinking, wanted to run many simulation kind of the same time and having a coherent data frame where to put this data. And ideally, I wanted even my simulation to be able to exchange information. So I needed a format that allowed data to be read and written very fast on or relatively fast from the disk, because at the end, Zarr is written on disk. And so I ended up on Zarr, as I told you before. But one thing that was useful was say, okay, I'm running my different simulation, and all of these simulation have different parameter sets. So where I do put my parameters, how they need to be, if I put them in an array, like the data that we have seen so far, well, they have to be very, very much like NumPy array. And NumPy array, they don't like strings unless you put codecs. You start using codecs that encode string into number, so it's not the best way. But in this case, metadata come to help. So for each group, for each data array, you can have metadata, and these are in V3. They are written in this JSON file that we have seen before. I can show you also into here, because here, if I want, I can open it. And you say that there is not much here beside the format of the Zarr and the info that are important for the storage, but we have these attributes. This is our space. We can use it. When you in these attributes, you can put whatever you want, and you see that these are Python dictionary, JSON Python dictionary, and so it means that you can put whatever you want, as usual with Python dictionaries. And so if I, in this case, I exploit a little bit NumPy, root and group one are still defined from my previous cells, so they are still around in the memory. I didn't reset, so they are still around. So this will run, and I put very useful information, as you might see in my metadata. You might find a better use for your metadata structure, but jokes apart, is just to show you what happens. And now let's go if I put it in the grouped example, I should go there and I find again, as promised in attributes. Sorry, this. I have description, version, so a dictionary. All right, very, very convenient. Interestingly, and importantly, people that have developed Zarr have given us a way to access the attributes. And in V2, back in the days, or yesterday, we had this kind of formula, attrs, with this ATTRS acronym was referring to a file that was created separately from the attributes of the JSON. And then you will treat them exactly as a dictionary, as we are doing here. In V3, they have consolidated everything into this zarr.json file that is, again, in every group and in every data, and you access in the same way. But you don't go about into, ideally, you don't go about into changing it manually. That's what I wanted to say. There are built-in methods, all right? All right. Now, I will move forward. And now, one last bit, that is interesting. And again, please tell me if I'm going too fast or too slow. I wanted to show you what is the difference in loading and writing images with Pillow, the standard image writing reading library in Python, and Zarr, which handles arrays again, and images in a computer are arrays. I work a lot with images, so that's what I wanted to do. Now, I'm not sure the time is, I think the time might be running fast, so I'm not going to describe this code. It's a little code that compares and save and load images from our in one way or the other, right? And what we can see that random image writing with Pillow, we have an image that is a normal 1024 3 int 8, an RGB image that a normal one you would expect. And it takes a third of a second to write and a little bit less to read, but we see that Zarr is kind of outperforming by a good 7-8x. But this is perhaps funnier to do. We run a little bit more comprehensive search and analysis on this kind of, and I want to look at what happens if we make bigger, smaller arrays. But we do this. And I leave, again, I don't describe the code. Well, I could. I'm just scanning. I create this little function to create images in Pillow or in Zarr, and then return us how much it takes to load and what is the gain of the Zarr in comparison to the Pillow. Well, if it's negative, it will be there will be no gain. But let's see what happens. And we have chosen images as small as the 128, which are reasonable for AI. People use small images very often, but also big images. Big image might be the input for AI, because at the end you have high resolution images and you might want to chunk it, divide it, blah, 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 for working it better with them. And so there is a whole bunch of consideration you want to have in terms of how you handle your image. But this is, I think, the interesting part of all this data, besides my chit-chatting about something you can read online. This is, let's say, my contribution to the field. If you compare Zarr load with growing arrays, the orange line is acceptably flat, while the blue line ramps quite high. Yeah? And so when we are playing with images that are relatively big, we are taking half seconds and more to load images. And we see that our gain, let's say, goes around, this is a sum, about 10%, 10 times faster. When you are running and you're trying to fine tune an AI to an image vision model, a computer vision model, and you have a few examples, probably you want this process to be fast. 10x gain, I think, is a very, very big gain. And I'm talking about this because at least I'm not a big expert in AI, but last time I checked, people were doing things with Pillow. And it's very common practice, at least. So if people find this useful, I'm very happy that I contributed. I think this is good news for people wanting to do this thing.
Actually, Lorenzo, just for you to know, this is advertised in the DC Python meetup. This is advertised in the DC Python meetup, this meeting. The guy who writes Pillow, the main maintainer, his name is Alex. And you're saying that he's always looking for things to actually improve in Pillow for this or that reason. So this might be something that we might want to connect. Send me an email and I'll introduce you. So you'll show him this.
I'm not working on improving backhands, but this is interesting.
Just send me an email later. I'll introduce you. Okay.
Okay, doc. Okay. Let now kind of run because I don't want to bore people. So this is a fun example, just to demonstrate to you that it's true that they can you can write stuff in multiple processes in the same Zarr store. So I have to do a couple of imports. I have to use this particular way from multiprocessing because I'm in a Jupyter notebook and the standard multiprocess won't work. We'll have problems. So never mind. This is not a demo about multiprocessing. But then I want to write 100 images on a Zarr store at the same time. And I want to take not so much. 1.3 seconds. Let me see if I run it again. Yeah, that's better. He had to do a little bit of import. The first time he does things, it takes time. It's not bad writing 100 images in so little time. Let's write 1,000. And now it's taking slightly more. Yeah. Well, it didn't take so very much more, right? So another thing that is convenient, if you have multiprocessing available, things that you normally have, it's very available, very useful. Zip store, not a big thing. We are creating a store and we are kind of exporting this as a zip. I play. It's really so self-explanatory that I'm not losing your time so very much. As far as I check, it's not a normal zip. At least on my Mac, it doesn't unzip, but it unzips if you use its built-in. And you see that you return like this was an MP1s, and we return our NumPy ones. Now something perhaps more applied and interesting, but I will go fast, and then you can ask me questions. So if you are not bored, you will ask me questions. So let's say that we have this data structure. That is our fancy data structure for our app that does the best things. And we need to have experiments and results. For example, in my case, I had simulations that are saved into experiments, and I have 1,000 of those simulations. They will call experiment 1, 2, 3, 4, 5, 6, 7, 1,000, and each will have metadata because I will collect which kind of parameter setting are there, and then I will analyze somehow. And then I want to store the results of my E1 into results one, and it might have metadata or might not have metadata. It's just to show you the general idea that one might have. Oh, I want data structure that I can handle, but then I want to keep it coherent. I don't want people to kind of play with it in a strange way. So one good thing, I think I find it good practice, is to create your own data manager, where you simply create a class, a Python class, where you create infrastructure to run and load your Zarr, to write, create, load your Zarr store. You will create methods to write the metadata, to get the metadata. You will create methods to add an experiment, and you see that eventually things go really regress to what we have done so far. It's really always the same. And we can create some code to help us writing metadata in a programmatic way. We can add results, methods to get experiment, to analyze, and to get results. And if we, for example, do that, we might have a tool. Imagine that you have a PyQt app that needs methods from a class to kind of link to its own button and do the fancy things. No? And in this case, we do it programmatically. We create a manager at a certain path, and we write the metadata. We do the things that we have essentially encoded, and essentially what happens here. For example, just to have a little bit of fun. It's not funny, but yeah. My analyze experiment was just take whatever array you have and just take this slicing, and so the result will always be 20 by 20. Actually, it's not very smart, because if the input array was smaller, then there will be a problem, but it's not a big issue. So here for this example, I hope that everything is kind of self-explanatory, that we have created our root, our data structure, perhaps is more visible here. Here we have a little bit more data from our example before, and we have our results, our experiments. We have analyzed only E1, and so we have just corresponding to E1, E2. We have our usual metadata. So you see, we have done essentially everything we have done before, but programmatically. So this is a good way if you don't want to expose your data structure to other type of fiddling, or oblige people to fiddle with directly with Zarr. Finally, this is really, you see, I didn't even install the library for this, but I assure you that this strategy works. And to create a data loader for your machine learning, computer vision, fine tuning, for example. I want, and normally you will see, if you look at the manual, you will see that a PyTorch data set has a few, the boilerplate.
Before you run away with this, people don't know what a data loader is and what it's needed for. So if you can explain what happens there, that'll be helpful.
Yeah. No, I'm happy to. I was running because I'm afraid to be long, but I'm happy to
explain this point. Explain that point.
Yeah.
This will be interesting to many people.
Yeah. So when you use PyTorch or other AI ML tools, one of the big parts nowadays is to handle the data, because you always have training data set, validation data set, test data set. You have all the things that, but if you're training a large language model, there will be a body of text or chunks, chunked in a certain way, tokenized in a certain way. If you have doing computer vision, there will be images. And these are essentially what you have seen today. I'm always looking at the image side because it's what I do more. And a data set is an important bit, because PyTorch especially PyTorch want to see things in a certain structured way. It likes NumPy arrays like that, so they talk very well together, and it likes the data to be structured a certain way. So the kind of common practice in building a fine-tuning or a training algorithm for your computer vision, it would be to create a data set that is a class defined in PyTorch, and you can define it. And this kind of class, you will subclass, create your own spatial data set that where you can overwrite a few methods. And the interesting bits are, well, typically you have to redefine the init. So in our case, we will put a Zarr store with an open statement, something like that. And then our get item, where we can access directly our Zarr store. And you might ask, well, this looks stupid. It looks exactly like the class you showed us before. And the point is that is kind of exactly like the same. The point is that the people at PyTorch, I cannot say for other, for TensorFlow, for other, for JAX or others, but I think they are more or less on the same line. They have given us a certain prototypes, templates for working with making the work with the AI easier or more standardized. And this data set looks exactly like this kind of data structure we have talked about today. So in this case, we can almost one-to-one transport our data manager class into a data set, PyTorch data set, or even in this case, we don't even need to create a class. We already overwrite it in data set. And then it becomes, for if you have done this kind of exercise before, you know that when you want to load your data, you want to define a data loader that has certain parameters in terms of how it does pick from the data. And this is important for AI. You want to shuffle, so you don't pick always the same image for the same bit of the training. You normally have a batch size, which means how many images I pick at the same time and I handle at the same time. Another, and this is an highlight that I want to make. If one does AI, probably doesn't want to use, they don't necessarily want to use this particular way where you load one image at a time, because the good of Zarr is that the performance improves incredibly with the size of the array. So you can load 1,000 images in the same array, and perhaps you might create your data set or your data structure already ready for AI purpose, so that the load will be much faster. This is just for elaborating on this idea of the batch size and how much you can really tune your things in a way that then you find out that you can speed up things in a way that is incredible. And to make you, well, I don't need to make you an example because it's already.
Lorenzo, it's not only speed up. In this case, one of the biggest problems is that you have a lot of data. Like AI usually trained with lots of data.
Yeah.
So if you can reduce the disk inputs and do it faster and load and load things faster, and it takes less storage, then you can feed your AI.
Yeah.
Perhaps better. This will be the advantage, because AI has a limited amount of how much it can take at one. It's limited amount of intake. So this way, you're doing it more efficiently.
Yeah.
If I understand, did I describe this correctly?
Yeah, definitely. Yes, and in a controlled way. So it's everything is actually. If you have your, and this is something I'm doing lately. Well, not lately, but it's something I'm working on. Is extracting the right type of data, because AI nowadays has some problem. Depend. In certain domains we don't have data, and so we need to create them. And in some cases we have a lot of data, but they are not so good. They are not coherent. They might be different size, different resolution, different everything. No? So one thing that Zarr helps me doing in a practical way is sitting at the middle where I create apps or tools that store my data, my images in that way. And then I can link it to AI tools, multi-processing tools, and things like that in a kind of standardized way. And this is probably a good things to finish also because the Jupyter notebook is finished and all the rest might be just talk a little bit about this. And so on this note, I will show.
Does anyone have any? First of all, let's thank you for the nice presentation. So make some noise, or there's also ways to to thank you for this presentation. I do ask for anyone who has questions, come on. Was shy before, then they can actually come in and now ask it. Please do. Don't be shy. If something was over your head, it's okay to ask. Come on. Can't be that you're all still around without questions. I'll start with a question. So, like, how did you discover this library? Like, what was your need? What was the real problem that you were trying to solve that's like made you go towards Zarr?
Yes, let me think about the very first time I went there. I think it was really about writing concurrently the result of multiple concurrent run of my simulator, and then adding something that allowed two simulators living in different process talking together. And I was saying, okay, I do it by writing on disk. And I say, all right, let's demonstrate that you are not an engineer because nobody will use disk for doing this kind of movement of data. And then I thought, well, but it's the most efficient way in my case, because at the end of the day, this data in memory doesn't fit very well. And the bigger they are, the slower my program will be. And eventually I find Zarr, and I was surprised when I see how fast it is. And so I use Pillow all the times in terms of loading images in Python. And I was surprised how fast it is loading images and doing the various things that it does.
Well, this was very insightful, actually, because this is how things are being discovered. That's why we need all those libraries, because each one of them does something different that may be useful in one use case, but eventually the fact that Python has so many libraries allows you to do many things. Any more questions by anyone? We have a silent audience today. Let's just check the chat. Well, they just liked it. Well, if there are no more questions, I guess people are waiting for the second part. I'll give you questions. Questions going once. Questions going twice. Questions going 3 times. Okay, no more questions. So in that case, Lorenzo, I'll thank you again for
Thanks for having me.
The last part was very insightful. It should be maybe perhaps if I would edit those, and I don't edit those, I would put it at the beginning about how you discovered Zarr, because this is really
okay.
This is really the stuff that's like really like gets people to understand why you need those. But for now, I'm going to stop the recording. Don't go away. We're continuing doing stuff here, but just not on the record. So Lorenzo, again, thank you.